Swayam Prabha. Digital India. Educated India.
Welcome to the course Analysis of Variance and Design of Experiments. So, you can recall that in the last lecture we initiated a discussion on the incomplete block design, and we were trying to understand the meaning and interpretation of the different types of symbols which are used in the incomplete block design. And I personally believe that that once you understand the meaning, interpretation of these symbols and notations, I can assure you, I can promise you, there is no problem in the case of incomplete block analysis. The analysis of variance in the case of an incomplete block design can be developed exactly on the same lines as you have done in the past. But now, since you are trying to develop here the design in a very general setup, so you can expect that there will be some constraints, and those constraints have to be solved on the basis of the knowledge in the vectors, matrix theory and statistics. So, that is what we are trying to do. So, once again in this lecture I will try to explain you the symbols, notation and the meaning of different types of terminologies. And once you understand it, after that I will begin with the development of the analysis of variance, and for that you use simply the, for example, principle of least square, try to write down the sum of a square, try to differentiate it, get the normal equation and solve those, that is all. So, you can see that it is not difficult, but it is very important for you to understand the meaning of the symbols which are being used, and once again I will say, try to understand it very clearly. I will go very slowly, I will try to take very simple examples, and once you understand these symbols and notation, I can guarantee you, I can assure you there should not be any problem in understanding the analysis of variance in incomplete block design, right. Okay, so let us begin our lecture. So, now you can recall that in the last lecture we had introduced some symbols and their interpretations. So, just for the sake of quick review, I will just give you here a brief details that we had considered a small v to be the number of treatments to be compared, and these v treatment are to be compared in a small e number of blocks that are available to us. That means, we are going to divide the experimental unit into a small e number of blocks, and then Ki is the number of plots in the ith block, and Rj is the number of plot receiving the J treatment. So, obviously, I will go from here 1 to B and J will go from here 1 to V, and small n is going to indicate the total number of plots. So, and we had established in the last lecture that in case if you try to take the sum of all Rj's, that is R1 plus R2 plus Rv, and if you try to take the sum of all the Ki's, that is K1 plus K2 plus Kb, that is going to be the same as the number of plots, total number of plots. And we have a very general condition here that each treatment may occur more than once in each block, or it may not occur at all. And for this thing we require a symbol here, which is here Nij. So, Nij is going to indicate the number of time the J treatment occurs in the ith block. And in case if you try to take here, for example, say Nij equal to 1, this means the J treatment occurs in the ith block once and only once, and in case if you try to take here, for example, Nij is equal to 0, this means that the J treatment does not occurs in the ith block, right, at all. And if you try to take the sum over J for this Nij's, then this came out to be as Ki. And if you try to take the summation over Nij with respect to I, then it was coming out to be say Rj, and if you try to take the summation over Nij for all values of I and j, then this was equal to here say small n, that is the total number of plots. So, this exercise we had done in the last lecture. So, now we try to consider some more concepts here, and now when you are trying to complete the incomplete block design. So, it suggests that there are going to be two factors at least, that is the block effect and the treatment effect. So, you will need here a symbol like Yij to indicate a outcome. But in this case, if you try to see, you are trying to consider a very general setup. You are trying to say that any treatment may occur once or more than once in any block, or not even occur at all. So, in order to incorporate that feature, we introduce here one more subscript, which is here like as here M. So, in the case of incomplete block design, we are going to represent the response or the yield from the mth replicate of J treatment in the ith block as Yijm, right. So, I is going for block, J is going for the treatment, and M is indicating the mth replicate. So, now if you try to see how many times treatment is being replicated in the block, this number is being indicated by the number Nij. So, in this case, the range of I is going to be from 1 to B, which is the number of blocks, the range for J, which is indicating the treatment, that is going to be 1 to V, and the range for M is going to be from 1 to Nij, because Nij is the number that is indicating that that a treatment is replicated in a block for how many number of times, right. So, now we are going to consider this setup, and we are going to consider this Yijm in the form of a two-way model. So, let us express here Yijm is equal to beta I plus tau j plus epsilon Ijm, where beta I is the block effect from the ith block, tau j is the treatment effect from the jth treatment, and epsilon Ijm, as we know, that is the random error component, right. Now, one thing you have to be clear here, that if you recall that when we initiated the discussion on analysis of variance, then first we had considered the model without any interceptum or without considering the general mean effect. And later on we had introduced the term of general mean effect in the model, and then accordingly we had modified the model. But now you have an experience that whether you are considering one way, two way, etc., under the given conditions of the design or the model, mu was always estimable, right. So, now just in order to make the things more simple, and the way I can explain you easily, I am not considering here the presence of interceptum in the model, but I am simply consider here a model like Yjm is equal to beta I plus tau j plus epsilon Ijm, and I will try to do my analysis and try to develop the tools on this model. And once I have explained you the intricacies involved in the analysis, after that we can very easily introduce the general mean effect in the model and can conduct the entire analysis without any problem, right. So, that is where you have to be careful, and at this moment I am trying to express the model as in the format of Yijm with the subscript, and later on the same model and the same setup will be expressed in the framework of a vectors and matrices. So, you always have to keep in mind that what are we going to do at a later stage. So, in this model we are going to use the following terminologies: block totals, treatment totals, and grand total, right. So, if you try to see, there are small p number of blocks. So, the block totals are indicated by capital B1, capital B2, and so on. So, we are going to have here B1, B2, BB, right, where your block totals from the ith block, which is indicated by here Bi, that is going to be summation over J and M on Yijm. And similarly, the treatment totals, there are the V treatments. So, these treatment totals I am trying to indicate here by V1, V2, VV, right, where the jth treatment total or the treatment total due to the jth treatment is obtained by double summation over IM over Yigm. So, now you can see here that it is not difficult for you to remember. This block totals, they are capital B, and the number of block totals, they are small b, and the treatment total, they are capital V, and the number of treatment total, they are small v, right. So, I am trying to make the symbols as simple as possible, so that you can recall them easily without much problem. Now, the grand total is the sum of all the observations. So, that is simply going to be triple summation over Ijm over Yigm, that is going to be indicated by here capital Y, right. So, now you can see here that whenever you want to define or illustrate the setup of a design or a block design, then we need here the value of V, B, R, K and N. So, these V, B, R, K and N, they are called the parameters of the design, and in general design is indicated by the notation D and inside the parenthesis V, B, R, K, N, because these are the 5 parameters which are going to describe the setup and structure of the block design. Right. So, now let me try to take here very simple example and try to show you what is the meaning of this Bi, tau j, Tj, etc. Right. So, let us try to consider that an experiment is being conducted in 3 blocks, and their names are block 1, block 2, block 3, and there are 5 treatments. So, those 5 treatments are indicated by tau 1, tau 2, tau 3, tau 4, tau 5. So, now according to your symbol, the total number of blocks which is indicated by small b, that is going to be 3, and total number of treatment that is indicated by small v, that is going to be 5. Now, you see these 5 treatments can be arranged in 3 blocks in any way, that is the choice of the experimenter. But here I am trying to take a particular setup so that I can explain you the basic definitions. Okay. So, now I consider here block 1 which has 5 plots. Which are indicated here plot 1, plot 2, plot 3, plot 4, plot 5, and then I am trying to give the treatment number 1 indicated by tau 1 in the plot number 1. Then in plot number 2, once again I give the treatment number 1. Then in plot number 3, I try to give the treatment number 2. In plot 4, I give treatment number 2, and in plot 5, I give here treatment number 3. So, you can see here that treatment number 4 and 5, they are not given in block 1, and this treatment number here 1 is given 2 times, and the same is for the treatment number 2 also, that is also given 2 times. And similarly, if you consider the block number 2, this has got here 4 plots, plot number 1, 2, 3 and here 4, and the way we are trying to give the different treatment to these blocks is as we give treatment number 2 to plot number 1, treatment number 4 to plot number 2, treatment number 5 to plot number 3 and treatment number 5 to plot number 4, right. And similarly, we try to consider here the block number 3 which has only 2 plots, and both the plots we give here the treatment number 2. So, you can see here that in block number 2 the treatment number 5 is given 2 times, but treatment number 1 is, and treatment number 3 they are not given. And in the block number 3 no treatment tau 1, tau 3, tau 4, tau 5 are given. So, you can see here this is a very general structure, very general setup. So, now we try to use this structure and we try to see how different symbols etc. They can be interpreted using this structure. So, you can see here I have copied the structure of these blocks 1, 2 and 3, so that you can understand the interpretation easily. So, the first symbol we are going to address is Ki. So, Ki was the total number of plots in the ith block. So, you can see here block 1 has 5 plots, 1, 2, 3, 4, 5. So, this K1 is going to be 5. And similarly, the block number 2 has 4 plots, 1, 2, 3 and here 4. So, you can see here block number 2 will have the value of K as K2 is equal to 4. And similarly, the block 3 has 2 plot number 1 and plot number 2. So, K3 is going to be 2. So, you can see here that it is not very difficult to understand these values, right. Now, the next symbol we had used it was Rj. So, there are here 5 treatment tau 1, tau 2, tau 3, tau 4 and tau 5. So, j will go from 1 to 5. So, we are going to have here 5 values of R1, R2, R3, R4 and R5. So, now let us try to understand one by one how these values are coming. So, first try to understand what is this here R1. So, R1 is the number of time the first treatment tau 1 appears in the block. Which blocks? 1, 2 and 3, right. So, now if you try to see in the block number 1, the tau 1 is appearing here and here 1, 2 times. So, this is what I have written here, that the number of times the tau 1 appears in block number is 2. In block number 2, you can see here there is no first treatment available. So, this value is going to be here 0, and the total number of times the first treatment appears in the block number 3, this is again 0. So, this is here 0. So, now you can say that the total number of times the first treatment is appearing in the entire design, that is in all the 3 blocks, that is going to be here 2 plus 0 plus 0, which is here 2. So, the value of R1, this is going to be 2. Okay. And now, similarly we try to find out the value of R2, R3, R4 and R5. So, you can see here the total number of times tau 2 appear in block number 1. You can see here this is here and here. So, I can write down here like this here 2, and total number of times the treatment number 2 is appearing in the block number 2. So, you can see here that this is only here. So, I can write down here that in block 2 this is equal to 1. And what about in block number 3? You can see here that the treatment number 2 is appearing here in plot number 1 and plot number 2. So, in block 3 this value comes out to be here 2, and the total number of times the treatment number 2 appears in the entire design, that is the block 1, 2 and 3, this is 2 plus 1 plus 2, which is equal to here 5. So, R2 becomes 5. And similarly, if you try to consider here for R3, so R3 is the if you try to count that how many times that the treatment number 3 is appearing in block number 1, 2 and 3. So, you can see here in block number 1 tau 3 is appearing here in plot number 5. There is no block in block number 2, there is no plot where the treatment number 3 is appearing. You can see here it is 2, 4, 5 and 5, right. And similarly, in the block number here 3, there is no plot in which the treatment number 3 is appearing. So, I can write down here that the number of times tau 3 appears in block 1 is 1, block 2 is 0 and block 3 here is 0. So, the total number of times tau 3 appears in the entire design will be 1 plus 0 plus 0, which is so R3 has a value here 1. And similarly, for the treatment number 4, you can see here that treatment number 4 is not appearing here in this block number 1. Then in block number 2, this treatment number 4 is appearing here in plot number 2, and in block number 3 it is not appearing at all. So, the number of times tau 4 appears in block number 1 is 0, block number 2 is 1 and block number 3 is 0. So, the total number of times tau 4 appears in the entire design is simply here 0 plus 1 plus 0, which is here R4 equal to 1. And similarly, if you try to see for here R5. So, the total number of times the treatment number 5 is appearing in block number 1, you can see here this is 0. There is no treatment number 5 in block 1. And similarly, here in block number 2, if you try to see here, treatment number 5 is appearing in plot number 3 and plot number 4. So, in this case, this is appearing 2 times, right. And similarly, if you try to see here in block number 3, tau 5 is not appearing at all. So, I can express that the total number of times tau 5 appears in block number 1 is 0, block 2 is 2 and block 3 is 0. So, the total number of times the treatment number 5 is appearing in the entire design is indicated by the value R 5, which is 0 plus 2 plus 0. This 0, 2 and this 0 and this is equal to here 2. So, you can see here that all these values you can find very easily without any problem, right. The only thing is this, you have to just understand that how you are going to find such values, and you have to just keep in mind the basic definition. Now, similarly, now I try to illustrate how this Nij's values are found and what are they indicating, right. So, if you try to consider here the value of here N1j, that means I am trying to take here I equal to 1, right, that is the block number 1. So, you have to now consider only in this block number 1. So, now you simply have to count in the block number 1 that how many times a particular treatment is appearing. For example, let me try to count. So, in this block number 1, the treatment number 1 is appearing 1 and 2 times in plots 1 and 2. So, I can write down here this number is going to indicate that by the symbol N11. That means, the number of time the treatment number 1 appears in the block number 1, that is equal to here. Now, you can see here 2, which is coming from here plots 1 and 2. And then what about the treatment number here 2? If you try to see here, treatment number 2 is appearing here in plot number 3 and plot number 4. So, this number here is 2. So, I can say here that the total number of times that tau 2 appears in the block number 1, this is indicated by here N12 and this is appearing here in plots say here 3 and 4. So, this number here is 2. And similarly, if you try to see what about the treatment number 3 in this block number 1, you can see here treatment number 3 is appearing here in plot number 5. So, I can write down that the total number of times treatment number 3 appears in block 1, this is indicated by the symbol N13, that is equal to here 1. So, this is appearing in plot 5. And what about treatment number 4 and treatment number 5? You can see here there is no occurrence of treatment number 4 and treatment number 5 in this block number 1, right. So, these numbers are going to be indicated by N14 and N15, that is the total number of times tau 4 appears in block 1 and the total number of times tau 5 appears in block 1, they are going to be simply 0. So, you can see that it is not very difficult to find out such Nij's, and similarly if you try to consider here say here N2j, that is I equal to here 2, which is here block number 2. So, now you have to concentrate only on this block number 2. So, you can see now you can do the similar exercise and count that how many times a particular treatment is occurring in block number 2. So, if you try to see say about treatment number 1, you can see here that there is no occurrence of treatment number 1. So, that is going to be indicated by the number N21, that is the total number of times tau 1 occurs in the block number 2, that is N21, that is equal to here 0. And similarly, if you try to see for treatment number 2, so you can see here treatment number 2 is occurring here in plot number 1. So, in this case the total number of times tau 2 occurs in block number 2 is given by N22, that is equal to here 1 times. And similarly, if you try to see here what about the treatment number 3? Treatment number 3 is not occurring in plot number 2 and 3 or say 4. So, this value becomes here 0, right. Similarly, if you try to consider here the treatment number 4, you can see here treatment number 4 is occurring here in plot number 2 and that is appearing once in this block number 2. So, I can write down here the total number of times tau 4 appears in block 2 is indicated by the number N24, which is equal to 1. And similarly, for here the treatment number here 5. So, treatment number of 5 you can see here that is coming here in say plot number 3 and here 4. So, you can see here this is occurring in plot 3 and 4. So, I can write down here total number of times tau 5 appears in block number 2 is indicated by the symbol N25 is equal to 2. So, you can see here it is not difficult to find out such things, and similarly you can find out here the values of N3j, that means I equal to here 3, and you are going to consider here the block number 3. So, you have to look into this block number 3. So, the total number of times you can see a particular treatment is occurring in this block number 3. So, you can see here in the block number 3 only tau 2 is occurring here. So, and all other treatment tau 1, tau 3, tau 4 and tau 5, they are not occurring at all. So, I can write down here that number of treatments tau 1 appears in the block number 3, it is indicated by here N31, which is equal to 0, and total number of times tau 2 appears in block number 3, that is indicated by N32, this is equal to here 2. And similarly, the number of times the tau 3, tau 4 and tau 5 appears in block number 3, they are going to be simply here 0 indicated by the values N33, N34 and N35, right. So, you can see here it is not difficult to understand these symbols and these quotations, and I am sure that my experience is that sometimes students get confused with these symbols and they start thinking that okay, incomplete block design is difficult. So, now I have illustrated you in the most simple way. Now, it should not be any problem for you to understand. Now, the next confusion comes how to indicate this value of YIJM, right. So, now I try to consider the same setup and I try to write down here the values of YJM. So, I have here this YIJM where I is going from 1 to 3, there are 3 blocks, J goes from 1 to 5, there are 5 treatments, and M is going from here 1 to Nij. So, now this Nij's values you have already found. So, now you simply have to use them here, right. So, if you try to consider here this block number 1. So, if you try to see here, this is your here plot number 1, right. Means I have removed here the plot numbers, so that the things do not become too clumsy here to explain you. So, this plot number 1. So, you are trying to take here this, try to consider here this Y111. So, this 1 is indicating the block number, and now this 1 is indicating the treatment number. Why? Because here you have here treatment number 1, right. Now, you have here one more here 1, KISS 1. So, you can see here this treatment number 1 is appearing in plot number 1 and here plot number 2. So, here in this case M is going from 1 to 2, right. So, that means, so here this one, the first one here in this case, that is indicating the first replicate of treatment 1 in the block number 1, and this here is Y112, that is indicating the, this is the second replicate, that means the second observation which is obtained by giving the treatment number 1 in the block number 1, right. Similarly, you can now similarly if you try to see here, we have repeated treatment number 2 in plot number 3 and 4. So, now you are trying to give here treatment number 2 in block number 1. So, this one is going to indicate the block number, this the second subscript 2 is going to indicate the treatment number, which is given by here tau 2, and the same thing is happening here also in the plot number 4. Now, if you try to see here, this one in this plot number 3 and this 2 and this plot number 4, they are going to indicate the first and second observation when treatment 2 is given in the block number 1. So, this is now indicated by Y21 and Y22, and this is going to be indicated by Y121 and this is going to be indicated by Y122. And similarly, if you try to look at here Y131, now you can say very easily that this is the observation in the block number 1 when treatment number 3 is given, and this is only here 1, that means the first observation. So, this is the first observation on the treatment number 3 in block number 1. So, you can see here it is not very difficult to understand it, you have to just concentrate and see how are you going to do it. Similarly, now if you try to consider the block number 2 here, what is this Y221? So, I can say here the treatment number 2 is given in the plot number 1 and block number 2. So, this is indicated by here y22, and then there is only 1 times the treatment tau 2 has been given. So, we have here 1 because here 1 and the corresponding observation plot from this plot is indicated by y221. And similarly, if you try to come to the second plot here y241. So, now you understand this is the observation in the block number 2 when treatment number this 4 is given, and this is the first observation on this combination. And similarly, if you try to come here and say here y251 and say y252. So, that is indicating that these are the observation in the block number 2, and then they are obtained after giving the treatment number here 5, which is indicating here this 5, and then this y25 is occurring 2 times. So, these number are indicated by here y251 and y252. So, that is indicating that the treatment number 5 has been replicated 2 times in the block number 2, and these are the observation y251 and y252. And similarly, if you try to see, now it is not difficult at all for you what is y321 and y322. So, that is indicating that these are the observation from the block number 3, which is here, on treatment number 2, which is here like this, and then this is the first observation and this is the second observation in plot number 1 and 2 respectively. So, now you can see here these observations can be indicated by these symbols using the 3 subscripts, and you can interpret them very easily. Now, in case if you try to see that how are you going to obtain the block totals and treatment totals from here. So, you can see here there are going to be say here 3 block 1, block 2 and block 3. So, if you try to take the sum of all the values which are occurring in the block 1, block 2 and block 3. So, they are going to give you the respective block total. For example, if you try to consider here the block number 1. So, you can see here this y111, y112, y121, y122, y131. These are the observations which are coming from the 5 plots in the block number 1. So, if you simply try to add them together, these are going to be some numerical values which are the outcome, right. So, this will give you here the value of B1, you can see here. And similarly, if you try to add here the values in the block number 2, which is y221, y241, y251, y252, which are here. So, this is going to give you here the value of capital B2. And similarly, if you try to take here the sum of y321 and y322, that is going to give you here the value of third block total B3, right. So, now you can see you can very easily obtain this block numbers. Now, I come to the treatment totals. So, treatment totals are given by those observations which are getting a particular treatment. So, for example, when I try to consider here V1. So, V1 is the total of all those observations which are getting the treatment number 1 in the entire design. So, you can see here in this entire design what are the plots where you are trying to give the treatment number 1, and you simply have to sum them together. So, you can see here you are giving the treatment number 1 here in block number 1 and say plot number 1 and plot number 2. So, this is equal to here y111 plus y112, and this is going to give you the value of treatment total V1. And similarly, if you try to consider here another total here V2. So, that means you simply have to identify the plots where you are trying to give the treatment number 2. So, you can see here in the block number 1, the plot number 3 and plot number 4, they are given the treatment number 2, and say block number 2, there is plot number 1 here, which is given the treatment number 2. And in block number 3, there are 2 plots, plot number 1 and 2, where you are given the treatment number 2, right. So, you can simply sum the respective values which are given here y121 plus y122 plus y221 plus y321 plus y322, and this is going to give you here the value of treatment total 2, right. And similarly, if you try to see here about the treatment number 3. The treatment number 3 has been given only at one place in block number 1 in say plot number 5. So, now V3 is equal to here simply 131, right. There is no other plot in which this treatment number 3 has been given, and similarly for the treatment number here, say here 4, you can see here there is only one plot in block number 2, which is the plot number here 2, in which you have given the treatment number 4. So, you can see here that treatment number 4, E4 becomes here only Y241, and similarly, if you try to look for here the plots where you have given the treatment number 5. So, there are only 2 plots where you have given the treatment number 5, which are in block number 2, you can see here and here, plot number 3 and 4, right. So, you can see here, you can write down here, see here V5 is equal to Y251 plus Y252 from here. Right. So, now you can see that obtaining these observation is not difficult at all, and the only thing is this, you have to simply understand what are you going to do. Now, after this what you have to do? You have considered the model, and remember, as I said, we are not considering here the model either interceptum or the general in effect, and later on we will try to introduce it, and we are going to continue with our analysis by considering the interceptum in the model. But at this moment, I would request you that you please try to concentrate on the type of complications what we are going to get when we are trying to consider such a general setup. So, now if you try to recall that we have used the principle of least squares in one way and two way analysis of variance in CRD, RBD, LSD, etc. So, now we try to use the same approach, and we try to write down here the sum of squares due to random errors, which is going to be here the triple summation over IJM and sum of squares of epsilon IJM, and we try to minimize it, and for that we simply use the principle of maxima and minima, and we try to differentiate here this sum of squares with respect to beta I and tau j, right. And then we try to obtain the normal equation, and then we try to solve it. Simplify them, and getting this equation is not difficult, but what you have to see what really happens when you try to solve these equations. So, first we try to differentiate here a capital S with respect to beta I, put it equal to 0, and you get here this normal equation. So, if you try to solve it here, if you try to bring this double summation inside the bracket over YIJM, so this will give you here BI. So, now that is your symbol which you have to recall. BI was the term double summation over JNM YIJM, and then if you try to take this this double summation inside the bracket over beta I. So, you can see here this beta I is independent of say here I. So, this beta I can write down here as a beta I double summation JM and here 1. So, this is what I have written here, and similarly if you try to bring the summation sign over this tau j. So, summation over j and m tau j, that will become here like summation over j tau j and summation over here m times here 1, right. So, if you try to see here, that is what I am trying to write down here, summation tau j and summation over here 1, and this summation is going over m. So, now that is a very simple algebra, right. So, if you try to see here what is happening, what is going to be here this quantity summation over j m here 1. This is simply going to be the total number of plots available in the ith block. So, this is going to be indicated by here k I. And what about here this quantity summation over m on 1, that is simply give you the value of nij's. How? For j equal to 1, that will be simply here n on 1, and if you try to change the values of here I from 1 to b. So, that is going to give you the value of here ni1, ni2, n and so on. So, I can write down here this thing here as say summation over j, tau j and Nij, right. So, if you try to simplify here, say for a given value of here I can write down here say Ni1 tau 1 plus Ni2 tau 2 plus up to here Niv tau v, right. So, for I goes from 1 to b, these are your here total b number of equation, and this quantity can be written here briefly here as a summation over j, tau j and ij. So, now we have here this equation b I is equal to beta I k I plus summation over j, tau j and ij. So, remember this thing, these are here small b number of equation, and similarly now if you after this we try to differentiate s with respect to tau j and put it equal to 0, and then we get here an equation double summation y I j m minus beta I minus tau j. Now, we have to do the same exercise that we have done earlier. I tried to bring this double summation inside the parenthesis. So, this becomes here double summation y I j m, and then I try to bring this double summation over this beta I and tau j. So, this becomes here summation over I beta I and summation over here m, and this will come here 1, right, as if you are trying to sum 1 1 1 say Nij number of times, and then the third term will become here tau j. This will be your here double summation over I m over this here 1, right. So, now if you try to see here this term here double summation y I j m summation over I and m, this is simply your here v j, and that was the symbol which you have had given earlier, and in the second term this term is going to be simply here Nij. So, that is the total number of times a particular treatment is occurring in a block, right. So, our symbol was Nij. So, this term becomes here summation over I beta I Nij, and similarly here if you try to take here this term here summation over m with respect to 1. So, that is again going to be here Nij. So, this term becomes here tau j into summation over I Nij, and the same thing we can write here very clearly, that Vj is equal to Nij beta 1 from here, and then this term can be simplified here as say N2j beta 2 plus up to here and Bj, because I is going from here 1 to B and j is going from here 1 to V. So, this can be here the last term will be Nbj into beta b plus Rj tau j, because this quantity here summation over I and Ij we had found earlier, it is simply equal to here Rj, and j is going from here 1 to V. So, we have here such V equations. Remember that this is not single equation, well, that is indicating the jth single equation, but altogether there are V equations. So, now briefly I can write down here this, that is Vj is equal to summation over I beta I and Ij plus Rj tau j. So, now you can see here this is your here this equation number 2, and this is here equation number 1. So, now this equation number 1, this is here total number is b, and for equation number 2 there the total number of equation here is v. So, now altogether we have here b plus v equations, and now if you try to see how many parameters you have here beta 1, beta 2 up to here beta b parameters, and tau 1, tau 2 up to here tau v parameters. So, altogether we have here b plus v parameters. So, we think that now we have got here b plus v equation, and there are b plus v parameter to be unknown. So, we can solve this equation and we will get the unique estimates, but this does not happen. That is what you have to see here. Now, we are coming to a very crucial point. Try to concentrate and try to see what is really happening, and this is the point where we have to be very careful, and then we have to see how we are going to solve this problem. In case if you try to sum the equation number 1 over all values of I goes from 1 to B, and equation number 2 over all values of j is going from 1 to V, you can write down here summation over I bi is equal to summation over j Vj, and if you try to see here the definition of Bi and Vj, this is simply the double summation y I j m, where this I and j are only changing. So, if you try to see here the quantity on the left hand side, this is triple summation y ijm, and the quantity on the right hand side is also the triple summation yijm, that is the grand total, the sum of all the observations. So, that means the B plus V equations are not linearly independent, right. At least you have found here one constraint. So, thus these B plus V equations which are looking as B plus V equations are not actually B plus V independent equation, but at least we know that there is one constraint. So, all the B plus V parameters cannot be solved, and there are now I can say that there are at most B plus V minus 1 degrees of freedom. Remember, I am trying to emphasize on the word at the most. So, that means only B plus V minus 1 parameters can be estimated out of B plus V parameters, right. So, that is now the constraint, and this is the problem which we have to handle to solve the problem in the case of incomplete block design. And later on I just want to show you here, I just want to inform you here that later on you will see that B less than or equal to B plus V minus 1 in special cases. And also note that one thing, if you try to recall that in the case of two-way analysis that you did earlier, or in during the case of randomized block design, you always assume the condition like summation alpha I equal to 0, summation beta j is equal to 0, and then you try to solve this problem. But at this moment we have not made any such assumption. We are simply trying to solve it without such condition, right. Now, you can see here, now all the B plus V parameters cannot be obtained uniquely from this B plus V minus 1 equations. So, now we have here two options if we want to estimate the parameters. Using equation 1, we can eliminate beta I from equation 2 and estimate the treatment effect tau j, or the second alternative is that using equation 2 try to eliminate tau j from the equation number 1 and try to estimate beta I. That is the same thing. For example, if I try to write down say x plus y equal to 2 and say x minus y equal to here 1, that is the same exercise once I shown you earlier, that you try to write down here x is equal to say here minus y plus 2, and then you try to replace this x over here minus y plus 2 minus y is equal to 1, and then you try to get here the value of y. Or the second option is this, from this equation try to write down here y is equal to 2 minus x, and then try to replace this y over here and the second equation and try to write down here x minus 2 plus x is equal to 1 and try to obtain here the value of x, right. But in this case we have two equations, two unknowns, and the equations are estimable. So, and they are linearly independent, so the parameters are estimable, but in this case this is not happening. So, now we try to attempt the approach number 1, because you see in practice we are more interested in estimating the treatment effects, right. You can always say that well, why I am not going first for the second approach. Yes, I will try to show you, but at this moment I want to show you that how are the things going to progress. So, we consider here the first approach, that using the equation number 1 we try to eliminate beta I from the equation number 2. So, you can see here this was your here equation number 1. So, you simply try to obtain here the value of here this beta I from this equation, and then try to substitute this beta I in this equation number here 2, right, and then try to obtain the value of here tau j. That is what we are going to do here. So, well, if you try to take your pen and paper and try to solve it, you can do it faster than what I am doing here. That is a very simple exercise. So, from equation number 1 we obtain here beta I is equal to 1 upon k I into b I minus summation over j n I j tau j. And now we are trying to substitute this value of beta I in equation number 2. So, equation number 2 was here like this, n 1 j beta 1 plus up to here and b j beta b plus here r j tau j. Now, I try to substitute here the value of beta 1 here like this, which is obtained from here just by substituting I equal to 1, and then I try to obtain here the value of here beta 2 from here, and I try to obtain here the value of beta b here like this from this using this beta I. Now, you can see here that in every term there is a term related to here tau 1, tau 1, tau 1, which has got different coefficients n 1 1, n 2 1 up to here and b 1. So, my objective is now there is no more statistics, I am simply trying to solve this problem. So, what I try to do, I try to collect all the terms of here tau 1, tau 2, tau v separately. So, that is what I am trying to do here. So, if you try to see here, this is the same equation which I have just written, and now I try to collect here the coefficients of here tau 1 from each of the term, and then I am trying to write down here this you can see here. So, all the term which are here, for example, this will be here, this will also come here. So, I am trying to write down here this term here you can see, and this term here n 2 j into n 2 1 you can see here divided by k 2 and so on. So, and then I try to do the same exercise with each of the coefficient tau 1, tau 2, tau v, and you can see here for this here tau v, what I am doing here, this is say n 1 j into n 1 v which is coming from here and divided by this k 1, and similarly from here n 2 1 into n 2 j divided by here k 2, and simply here n b v into n b j divided by k b here, and this term here r j tau j, this appears here as such. So, now I try to write down all these terms. This is very simple thing, right. It looks more complicated when I am trying to do it on the slide, but if you try to see, this is very simple, and then I try to write down this these terms in a simple way just by summation. So, I can write down here V j is equal to summation over I n I j b I divided by k I, and then tau 1, tau 2, tau v along with their respective coefficients plus r j tau j. Right. So, now if you try to see here the same thing which I have written here as this quantity V j minus summation over I n I j b I k I, this I can denote by here q j, and then I am trying to write down here all the terms as such, right. And this q j is given by here like this. This is called here as say adjusted treatment totals, right. And if you try to see here, you have got here a term like V j n 1 j b 1 upon k 1 and b j b b upon k b and so on, right. So, but if you try to see in the case of the complete block analysis, this treatment total was given only by V j. But now, what are you trying to do? You are trying to subtract this q j by this term. You are trying to adjust the treatment total by a certain factor. So, that is why this q j is called as adjusted treatment totals, right. And we say this that this adjustment is being made here with respect to the block effects, which are indicated by B 1, B 2, B B. So, this adjustment is being made for the block effect because they were eliminated to estimate the treatment effects, right. So, that is why this q j is called here as say adjusted treatment totals, and in this case you can see here k I is the number of plots in the ith block. So, if you try to consider the term here B I upon k I, that is called the average yield or say average response per plot from the ith block, and if you try to multiply the B I upon k I by n I j, then this quantity is considered as an average contribution to the jth treatment total from the ith block, and q j is obtained by removing the sum of the average contribution of the B block from the jth treatment total V j, right. So, this is what you have to understand. So, now we come to an end to this lecture, and you can see here we started with a very simple setup. I tried my best to give you the idea about all the basic definitions, and now towards the end we have understood the complications that arise in comparison to the complete block analysis, right. So, of the designs of experiment. So, I would request you try to take one more example and try to find out all these values yourself, and the algebra which I have shown you on the slides, try to do it with your own hand, that will give you confidence. So, you try to practice it, and I will see you in the next lecture where I will try to take this analysis further. So, you practice, and I will see you till then. Goodbye.